The morning of March 23, 1943, El Guettar, Tunisia. Through the dust and heat shimmer rising off the North African desert, Sergeant Frank Morrison watched 57 German tanks roll toward his position. Panzer 3s and 4s, their grey-green hulls creating dark silhouettes against the pale sand. Morrison commanded an M10 tank destroyer, one of 31 scattered across the rocky hills east of El Guettar. The 1st Tank Destroyer Battalion had been in theatre for exactly 4 months, and this was their first real test against massed German armour. The Germans called it Operation Capri, a counterattack by the 10th Panzer Division designed to smash through American positions and relieve pressure on the Afrika Korps. German intelligence had identified the American tank destroyers during reconnaissance flights. The reports described them as modified Sherman tanks with open turrets and 3-inch guns, slow, vulnerable, nothing the experienced Panzer crews couldn't handle. The Germans had been fighting in North Africa since 1941. They'd crushed British armour at Gazala, torn apart French positions at Kasserine Pass just a month earlier. These new American tank destroyers represented just another obstacle to be eliminated on the road to victory. Morrison's gunner, Corporal James Rivera, was already traversing their 3-inch gun toward the advancing German column. The M10's thin armour, barely an inch thick in places, wouldn't stop a direct hit from a German 75mm gun. But that wasn't the point. The tank destroyer doctrine that Morrison had learned at Camp Hood in Texas was simple. You don't slug it out with enemy armour in a toe-to-toe fight. You find a good position. You wait. You shoot first. Then you move before they can shoot back. Speed wasn't just about how fast your vehicle could drive. It was about how fast you could think, how fast you could shoot, and how fast you could disappear. Tanks kept coming, confident in their approach. Their commanders had fought the British 8th Army for 2 years. They knew how tank battles worked. You advanced methodically, using superior tactics and veteran crew experience to overwhelm the enemy. The thick frontal armour on their Panzer IVs could deflect most Allied anti-tank guns. The long-barreled 75mm guns could kill at ranges exceeding 1,500 yards. These Americans were about to learn what happened when inexperienced crews faced the Afrika Korps. At 08:30 hours, Morrison gave the fire command. Rivera's first shot struck a Panzer IV at 800 yards, penetrating the side armour and detonating the ammunition storage. The explosion threw the turret 20 feet into the air. Before the German column could react, 30 more M10s opened fire simultaneously from concealed positions across the hillsides. The ambush was perfect. The Germans had expected to find the American tank, destroyers in fixed defensive positions, easy targets for their experienced gunners. Instead, the M10s had positioned themselves using terrain that German reconnaissance had dismissed as impassable for tracked vehicles. The 3-inch gun on Morrison's M10 could penetrate 3 inches of armour at 1,000 yards. Not impressive compared to German 88mm guns, but more than adequate against the Panzer IV's 2-inch side armour. And the Americans weren't shooting at German frontal armour. They were shooting at flanks, at engine decks, at the vulnerable points German doctrine had trained crews to protect by maintaining proper formation and mutual support. Except the Americans weren't giving them time to form up or support each other. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The battle lasted 11 hours. German tanks tried repeatedly to maneuver into positions where their superior frontal armour and more powerful guns could dominate. But every time they turned to face one American position, M10s from different locations would hammer their exposed flanks. The tank destroyers were moving constantly, using wadis and rocky outcroppings for cover, appearing just long enough to fire 2 or 3 rounds before reversing behind terrain that blocked German return fire. Rivera would later describe it as the most terrifying and exhilarating experience of his life. Terrifying because one direct hit would penetrate their thin armour and kill the entire crew. Exhilarating because they kept hitting German tanks that never saw them coming. By sunset, 38 German tanks lay burning across the desert floor. The 10th Panzer Division's counterattack had collapsed completely. The 601st Tank Destroyer Battalion had lost 21 of its 31 M3 gun motor carriages, the half-tracks that some units still used before the M10 arrived in. Numbers. 7 of the new M10s had also been destroyed. The casualty exchange rate looked brutal on paper, but the Americans had accomplished something more important than any kill ratio. They'd stopped a veteran German armoured division cold. The Afrika Korps was no longer invincible. That night, Morrison sat beside his damaged M10 and thought about what they'd learned. The Germans had expected a conventional tank battle where experience and superior equipment would prevail. Instead, they'd encountered a completely different approach to armoured warfare. The M10 wasn't designed to be a tank, it was designed to kill tanks by refusing to fight them fairly. And fair fights, Morrison was beginning to understand, were something America couldn't afford and didn't need. Not when they could build better doctrine instead. The story of how the M10 became America's most widely produced tank destroyer begins 2 years earlier, in the wreckage of France, June 1940, and German Panzer divisions were tearing through Allied defences with a speed and violence that shocked military observers worldwide. The Blitzkrieg doctrine that German theorists had developed during the 1930s was proving devastatingly effective. Concentrated armour, supported by dive bombers and mechanized infantry, punching through weak points in enemy lines and racing deep into rear areas. Traditional anti-tank defences, based on fixed gun positions, spread thinly along the front, couldn't stop them. By the time defenders could identify where the German breakthrough was happening, the Panzers were already miles behind friendly lines, destroying headquarters units and supply columns. American military planners watched the fall of France with growing alarm. The United States Army in 1940 had exactly 464 tanks, most of them obsolete light tanks from the 1920s. If German doctrine proved this effective against the French and British armies, what would happen when the Panzers turned their attention toward American forces? The standard American response to the tank threat involved towed anti-tank guns assigned to infantry divisions. 37mm guns that could barely penetrate German armour, positioned in static defences that Blitzkrieg tactics were specifically designed to bypass. Something had to change. In December 1941, the United States Army established the Tank Destroyer Force as a new branch. The concept was revolutionary. Instead of spreading anti-tank guns thinly across the entire front, concentrate them in mobile battalions held in reserve at corps or army level. When German armour achieved a breakthrough, rush the Tank Destroyer battalions to that location and destroy the enemy tanks before they could exploit their penetration. The Tank Destroyer Center at Camp Hood, Texas, developed a doctrine based on 3 words: seek, strike, destroy. Find the enemy armour. Race to an advantageous position. Kill it. Then move before the enemy can respond. This doctrine required vehicles that prioritized mobility and firepower over protection. Traditional tanks were designed to absorb hits while advancing toward objectives. Tank destroyers were designed to avoid getting hit in the first place by being somewhere else before the enemy could aim. The early attempts at creating these vehicles were crude. The M3 gun motor carriage mounted a 75mm French howitzer on a half-track chassis. The crew crouched behind a thin gun shield with minimal protection from artillery or small arms fire, but the concept showed promise. At Guettar, those vulnerable half-tracks had proven they could kill German tanks when used correctly. The army wanted something better. A fully tracked vehicle with a rotating turret, enough armour to protect against shell fragments and small arms, and a gun powerful enough to penetrate German armour at combat ranges. Most importantly, it had to be fast enough to execute tank destroyer doctrine, get to the ambush position before the enemy arrived, fire, displace to a new position before return fire could be effective. Speed wasn't a luxury, it was survival. The prototype that became the M10 emerged from testing at the Aberdeen Proving Ground in Maryland during early 1942. Engineers started with the M4 Sherman tank chassis, already in production and mechanically reliable. They removed the Sherman's turret and replaced it with a new pentagonal design mounting the 3-inch gun M7. This gun had originally been developed as an anti-aircraft weapon, but it proved equally effective against armor. At 1,000 yards, it could penetrate 3 inches of homogeneous armor angled at 30 degrees from vertical. That was enough to defeat the Panzer III and Panzer IV tanks that formed the backbone of German armored divisions. The armor protection told the real story of tank destroyer philosophy. The M10's frontal armor measured just 2¼ inches on the gun mantlet, 1½ inches on the upper hull front. The sides were even thinner, less than an inch in places. A Sherman tank had twice that protection. But the M10 weighed only 32½ tons compared to the Sherman's 33 tons, despite mounting a more powerful gun. The weight savings came from reduced armor and an open-topped turret. That open top gave the crew excellent visibility for spotting targets and escaping quickly if the vehicle was hit. It also made them vulnerable to artillery airbursts and grenades. The army accepted that trade-off. Visibility mattered more than overhead protection when your survival depended on seeing the enemy first. The engine choice revealed American pragmatism. The M10 variant used the General Motors 6046, a unique design that mated 2 Detroit diesel 671 inline engines to a single output. Each engine produced 187.5 horsepower for a combined 375 horsepower. If one engine was damaged, the crew could disconnect it and operate on the remaining engine, though at reduced performance. This redundancy proved invaluable in combat. The M10A1 variant used the Ford GAA engine, 450 horsepower from an 8-cylinder design adapted from a failed aircraft engine project. Both engines gave the M10 a respectable top speed of 30 miles per hour on roads, 20 miles per hour cross-country. 30 miles per hour doesn't sound impressive compared to civilian vehicles, but in 1942, most tanks struggled to exceed 25 miles per hour under ideal conditions. The German Panzer IV managed 25 miles per hour on roads, maybe 15 cross-country. The M10's speed advantage wasn't overwhelming, but it was real. More importantly, the M10 could sustain that speed over long distances. The range of 200 miles on internal fuel gave it operational flexibility that heavier German tanks couldn't match. You could reposition an entire M10 company 20 miles in under an hour, getting them to threatened sectors before German armor could exploit a breakthrough. The gun itself represented American industrial thinking at its best. The 3-inch M7 gun was powerful enough to kill any German tank then in service, but simple enough to manufacture quickly. The barrel was 52 calibers long, meaning 52 times the bore diameter. This length gave the gun its high muzzle velocity of 2,600 feet per second, which translated directly into armor penetration. The longer the barrel, the more time the expanding gases from the propellant charge could accelerate the projectile. Physics, not magic. And physics said that a 3-inch projectile, moving at 2,600 feet per second, carried enough kinetic energy to punch through 2 inches of steel plate at 1,000 yards. The ammunition variety gave M10 crews tactical flexibility, armor-piercing shot for killing tanks, high-explosive shells for destroying bunkers and engaging infantry, smoke rounds for creating concealment, white phosphorus for marking targets or setting fires. Each M10 carried 54 rounds of 3-inch ammunition, split between different types depending on the expected mission. Tank destroyer crews learned to load mixed ammunition racks, keeping armor-piercing rounds easily accessible, but having high explosive available for targets of opportunity. You never knew what you'd encounter on the battlefield. The turret design sparked controversy from the beginning. Unlike the Sherman's powered turret that rotated using an electrical or hydraulic system, the M10's turret was manually traversed. The gunner and commander turned a hand crank to rotate the turret. A full 360-degree rotation took approximately 80 seconds of continuous cranking. That's slower than a Panzer IV's hydraulic traverse, which could spin the turret 90 degrees in about 15 seconds. American tank destroyer crews hated the slow traverse in close-range engagements, but the decision to use manual traverse had sound reasoning. Powered turret systems added weight, complexity, and vulnerable components. If a hydraulic line was hit, the entire traverse system failed. A hand crank might be slow, but it was reliable and could be repaired with basic tools. Tank Destroyer doctrine said you should never be in a position where turret traverse speed mattered. If you were having to rapidly rotate your turret to engage multiple targets in quick succession, you'd already made tactical errors. The correct approach was to position your vehicle so the gun was already aimed at the expected threat axis. Enemy appears. Fire. Reverse behind cover. Drive to new position with gun oriented toward next threat. The slow turret traverse forced crews to think about positioning and fields of fire instead of relying on mechanical systems to compensate for poor tactics. Production began in September 1942 at the Grand Blanc Tank Arsenal in Michigan, operated by the Fisher Body Division of General Motors. The same company that built Chevrolet automobiles was now building tank destroyers. This mattered more than most people realized. Automobile companies knew how to set up assembly lines for rapid production using standardized components. They knew how to train workers quickly and maintain consistent quality across thousands of vehicles. Military arsenals focused on precision and performance. Civilian companies focused on efficiency and volume. The M10 needed both. The production contract specified that M10s should cost approximately $47,905 per vehicle. That's about $835,000 in today's money after adjusting for inflation. Expensive, but roughly 20% cheaper than a Sherman tank, which cost $60,215. The cost savings came primarily from the reduced armor and simpler turret mechanism. Every dollar saved meant more M10s in the field, and tank destroyer doctrine emphasized mass over individual vehicle capability. Better to have 6 cheap tank destroyers that could engage from multiple directions simultaneously than 3 expensive ones attacking from a single axis. By December 1943, Fisher Body had produced 4,993 M10s. Ford Motor Company added 1,038 M10A1s using their GAA engine. Total American production exceeded 6,000 vehicles. The British received 1,650 M10s through Lend-Lease, calling them Wolverines. The name stuck in British service, though American crews usually just called them TDs, short for tank destroyer. Some of the British M10s were later upgraded with 17-pounder guns, creating the Achilles variant with significantly better armor penetration than the original 3-inch gun. The production numbers tell part of the story. The other part is how quickly American industry could produce these vehicles compared to German tank production. Germany built approximately 12,000 Panzer IV tanks throughout the entire war, from 1939 to 1945. 6 years of production, 12,000 tanks. America built over 6,000 M10s in just 15 months, then added 47,000 Sherman tanks, plus thousands of other armored vehicles. The sheer industrial capacity gap meant that even if German tanks were individually superior, which was debatable, America could afford to lose 2 M10s for every German tank destroyed and still come out ahead. Germany couldn't sustain those exchange ratios. But raw production numbers mean nothing if the vehicles don't perform in combat. The M10's real test would come in the fighting across North Africa, then Italy, then France and Germany. And the first major test at Guettar revealed both the vehicle's potential and its limitations. The 601st Tank Destroyer Battalion had destroyed 30 German tanks, vindicating the tank destroyer concept. They'd also lost 28 of their own vehicles, including 7 of the new M10s. Was that success or failure? The answer depended on whether you measured results by exchange ratios or by mission accomplishment. The mission was to stop the German counterattack. Mission accomplished. The exchange ratio looked ugly, but the 601st had been equipped primarily with M3 half-tracks, not M10s. The 7 M10s that were destroyed represented a fraction of the battalion's strength, and those M10s had performed significantly better than the vulnerable half-tracks. General George Patton, commanding the 2nd Corps in Tunisia, declared the tank destroyer concept unsuccessful after Guettar. His assessment focused on the heavy losses and questioned whether specialized anti-tank units were worth the resources invested in them. Other commanders disagreed. The 601st had been used exactly as doctrine intended, deploying as an organized battalion to stop an enemy armored breakthrough in open terrain. The fact that they succeeded, even at high cost, suggested the concept worked when properly applied. The debate would continue throughout the war, with tank destroyer advocates pointing to successes and critics highlighting the losses. The real lesson from El Guettar wasn't about exchange ratios or doctrine purity. It was about how American and German forces approached the fundamental problems of armored warfare. The Germans emphasized individual vehicle quality, crew training, and combined arms coordination. Their Panzer divisions were built around veteran crews operating sophisticated machines, supported by excellent tactics developed over years of combat experience. When everything worked perfectly, German armor was nearly unstoppable. The problem was that everything rarely worked perfectly. Vehicle breakdowns, fuel, shortages, crew attrition, and enemy air superiority all degraded German effectiveness over time. The Americans emphasized mass production, mechanical reliability, and tactical flexibility. The M10 wasn't the best tank destroyer anyone could design. It was the best tank destroyer American industry could produce in the quantities needed to equip dozens of battalions fighting across multiple theaters. It was good enough to kill German tanks when used intelligently. Good enough was the key phrase. In warfare, good enough equipment available in large numbers beats perfect equipment available in small numbers. The Germans never fully grasped that reality. The M10's performance in North Africa established patterns that would repeat throughout the war. When used according to tank destroyer doctrine, positioned in advantageous terrain with clear fields of fire, the M10 could devastate German armor. When forced to operate outside that doctrine, advancing across open ground or engaging in meeting engagements where German tanks could use their superior optics and crew training, the M10 suffered heavy losses. Success required commanders who understood the vehicle's strengths and limitations and employed it accordingly. Morrison's crew received 4 days of rest after El Guettar before returning to combat. Their M10 needed a new final drive assembly and track repairs, but the vehicle was mechanically sound otherwise. German tanks they'd encountered were scattered in pieces across the desert, wrecked by American artillery and tank destroyer fire. The tactical landscape was changing. The Afrika Korps was running out of tanks, fuel, and time. By May 1943, the last German forces in North Africa would surrender. The M10 had proven itself in its first campaign, and now it was heading to Italy for a much longer and more difficult test. The Italian campaign would show whether the M10 could function in terrain completely unlike the open deserts of North Africa. Mountains, narrow roads, small villages, thick vegetation. Everything that made tank destroyer doctrine difficult to execute. The Germans would be defending from prepared positions instead of launching mobile offensives. And the M10 crews would have to learn new tactics to survive in an environment where speed and maneuver were constrained by geography. The vehicle might be the same, but the war was about to change dramatically. June 24, 1944, Omaha Beach, Normandy. Lieutenant Tom Springfield pressed himself against the cold steel of the landing craft as German shells began falling into the surf around his convoy. His unit, a company of the 823 Tank Destroyer Battalion, was scheduled to land 20 days after D-Day. The plan had called for a quick deployment once the beachhead was secure. Instead, a combination of bad weather and confused orders had delayed them. Now they were landing 3 weeks behind schedule, bringing their towed 3-inch guns directly onto a beach that still received occasional enemy fire. Springfield watched as the ramp dropped and his men began pulling their 3-inch anti-tank guns through the surf. These weren't M10s. The 823 had been equipped with towed guns, weapons pulled behind trucks or half-tracks. Lighter than self-propelled tank destroyers, cheaper to produce, but vulnerable in ways that made every crew member understand exactly how fragile their protection was. A towed gun couldn't move under fire. Once you'd selected a position and dug in, you either destroyed the enemy or the enemy destroyed you. There was no third option. The battalion moved inland immediately, supporting the 30th Infantry Division's drive towards Saint-Lô. The hedgerow country of Normandy was proving to be a nightmare for American forces. Every field was surrounded by thick, earthen banks, topped with dense vegetation, creating natural fortifications that channeled American advances into predictable, killing zones. German defenders used the terrain brilliantly, positioning machine gun nests and anti-tank guns to cover every approach. The 823's crews learned quickly that their towed guns worked best when positioned in ambush. Find a gap in the hedgerow that provided a clear field of fire. Dig the gun in until only the barrel was visible. Wait for German armor to approach. Fire. Hope the Germans didn't have time to call in artillery before you could limber up the gun and displace. By early August, the battalion had destroyed 23 German tanks and armored vehicles while losing 16 of their own guns. The exchange ratio didn't look impressive, but the strategic situation was evolving rapidly. American forces had broken through German defences west of Saint-Lô. General Patton's Third Army was racing across France, threatening to encircle the entire German army group in Normandy. Hitler ordered a counterattack. Operation Lüttich would smash through American 5 positions at Mortain, drive west to the coast, and cut off Patton's supply lines. The plan required concentrating German armour at a single point, exactly the scenario American tank destroyer doctrine had been designed to counter. August 7, 1944, 04:30 hours. Mortain, France. Through the pre-dawn fog, Springfield heard the unmistakable sound of German armour approaching. Panzer engines, track clatter, the distinctive squeak of interleaved road wheels. His 3-inch gun was positioned at a road junction east of Mortain, one of 12 guns from A Company covering the approaches to the town. The 30th Infantry Division held defensive positions throughout the area, but they'd been expecting to advance, not defend. Nobody was properly dug in. Nobody had mines laid. The German attack was catching them completely unprepared. The first Panther appeared at 04:45, its hull barely visible through the morning mist. Springfield's gunner, Sergeant Miller, Rhine, waited until the range closed to 400 yards before firing. The armour-piercing round struck the Panther's front armour and deflected harmlessly into the sky. The German tank's frontal protection was too thick for a direct penetration at that angle. Rhine traversed slightly, aiming for the turret ring where the armour was thinner. His second shot penetrated, and the Panther lurched to a halt with smoke pouring from the turret hatches. But behind that first tank came 24 more, Panthers and Panzer IVs from the 2nd SS Panzer Division, rolling through the fog in company strength. The German plan called for overwhelming the American positions through sheer weight of numbers, accepting losses to achieve the breakthrough Hitler demanded. Springfield's gun crew managed to destroy 2 more German tanks before enemy return fire began falling around their position. A Panther's 75mm gun struck the dirt embankment, protecting their gun, showering the crew with rocks and metal fragments. German infantry was advancing alongside the tanks, trying to get close enough to assault the American gun positions with grenades and Panzerfausts. Across the battalion front, similar scenes were playing out. American gun crews firing desperately at advancing German armour, destroying some, missing others, watching their positions get overrun by sheer numbers. By 0600 hours, the Germans had broken through the initial defensive line. 11 of the battalion's 36 guns had been destroyed or captured. Springfield's gun was still in action, repositioned hastily behind a stone farmhouse, but they were running low on ammunition. Each gun had begun the battle with 30 rounds. They'd fired 23. 7 shots left to stop German armour that kept coming. The fog began lifting around 0700, and that changed everything. American artillery observers could finally see the German columns. Fighter bombers from the 9th Air Force appeared overhead, diving through breaks in the clouds to attack German tanks with rockets and bombs. Most critically, the German armour had lost the element of surprise. American commanders knew exactly where the breakthrough was happening and could concentrate their reserves accordingly. Tank Destroyer doctrine was finally being applied as it had been designed. Find the enemy penetration. Mass your forces at that point. Destroy the enemy before they can exploit their initial success. Springfield's gun destroyed its fourth German tank at 0730, a Panzer IV that had gotten separated from its supporting infantry. The German crew bailed out, running for cover as American artillery began falling across the entire battlefield. By 0800 hours, the German attack had stalled. They'd penetrated American defenses, captured Mortain, killed or captured hundreds of American soldiers, but they hadn't achieved the breakthrough. The 823 Tank Destroyer Battalion, despite losing 11 guns and suffering severe casualties, had inflicted enough damage to slow the German advance just long enough for American reserves to arrive. The battle continued for another week. German commanders kept pushing more armor into the Mortain sector, trying to restart their stalled offensive. American forces, now properly positioned and prepared, tore the German attacks apart. By August 12th, the counterattack had collapsed completely. The 823 claimed 14 German tanks destroyed during the battle. They'd lost 11 of their own guns. More importantly, they'd proven that towed anti-tank guns could stop German armor when used correctly, even at terrible cost. But the Pentagon was already drawing different conclusions. A report completed in December 1944 recommended phasing out towed tank destroyer battalions in favor of self-propelled units. The 823's performance at Mortain had been heroic, but heroism shouldn't be necessary to accomplish the mission. Self-propelled guns like the M10 could reposition under fire, could support advances without waiting for trucks to tow them forward, could execute the mobile warfare that tank destroyer doctrine emphasized. Towed guns were dead ends. In November 1944, the 823 began converting to M10s. Springfield watched as the new vehicles arrived, tracked vehicles mounting the same 3-inch gun his crews had been using, but in a rotating turret on a mobile chassis. The transformation changed everything about how his company fought. Instead of selecting a position and defending it to the death, they could now maneuver, fire, displace, attack from unexpected directions. The M10 wasn't fast like the M18 Hellcat that other battalions were receiving. 30 miles per hour was respectable but not revolutionary. What mattered was that they were finally mobile. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Battle of the Bulge began on December 16, 1944, with a massive German offensive through the Ardennes forest. Over 200,000 German troops, supported by 1,000 tanks, smashed through thinly held American positions. The 823, now fully equipped with M10s, was rushed north from positions along the Siegfried Line. By December 18th, Springfield's company was in Belgium, taking up defensive positions around the town of Stavelot. German spearheads led by SS Panzer columns were racing west, trying to reach the Meuse River before American reinforcements could arrive. The M10s of the 823 were positioned along roads leading into Stavelot, their 3-inch guns covering the approaches German armor would have to use. This time, unlike Mortain, the crews were in vehicles that could move. That mobility saved them repeatedly over the next 2 weeks. German Tiger tanks appeared on December 19th, massive 68-ton vehicles with 88mm guns and frontal armor nearly 4 inches thick. The M10's 3-inch gun couldn't penetrate Tiger frontal armor at any range, but it didn't have to. Springfield's platoon used tactics they'd learned in Normandy. Let the Tigers pass exposed flanking positions, wait until they committed to attacking what appeared to be the main American line, then attack from the side or rear where armor was thinner. Corporal Buell Sheridan's M10 crew destroyed 4 King Tiger tanks near Stavelot using those tactics. The King Tiger was Germany's most heavily armoured tank, nearly 70 tons of steel with frontal armour exceeding 7 inches thick in places, virtually invulnerable from the front. But the side armour was only 3 inches, and the engine deck was even thinner. Sheridan's crew waited in a concealed position as the German tanks advanced past them. When the Tigers were focused on targets to their front, Sheridan's gunner fired into the engine compartment of the lead tank at 300 yards. The King Tiger burst into flames. The second shot disabled another Tiger. The third and fourth shots destroyed the remaining two tanks before the German crews even realized they were under attack from their flank. The 823's after-action reports from the Bulge documented dozens of similar engagements. M10s, using mobility and terrain to compensate for their thin armor and relatively modest gun power. They couldn't fight German heavy tanks head-on. They didn't try. Instead, they fought intelligently, using speed to dictate engagement terms. The M10's 30-mile-per-hour top speed wasn't impressive compared to the M18 Hellcat's 55. But it was fast enough to reposition between shots, to escape when German return fire got too close, to execute the hit-and-run tactics that tank destroyer doctrine emphasized. By the time the Bulge was eliminated in late January 1945, the 823 had destroyed another 40 German tanks and armored vehicles. They'd lost 18 M10s. The exchange ratio was improving as crews gained experience and learned to use their vehicles' mobility effectively. More importantly, they were surviving battles that would have destroyed towed gun battalions. Mobility was proving to be a form of protection more valuable than thick armor. The battalion crossed the Ruhr River on February 24th, then the Rhine on March 24th. By April, they were racing across central Germany toward the Elbe River. German resistance was collapsing, not from lack of will, but from lack of equipment. Panzer divisions that had fielded 100 tanks in 1944 were down to a dozen or fewer operational vehicles by April 1945. Fuel shortages, spare parts shortages, crew losses, Allied air superiority. The German army was disintegrating. The 823's final tally, compiled when the war ended in May 1945, showed 113 German tanks and armoured vehicles destroyed, 27 Panthers, 18 Tigers, and King Tigers. The rest were Panzer IVs, assault guns, and armoured cars. They'd lost 53 of their own vehicles, including both the original towed guns and the M10s they'd received in November. The statistical exchange ratio was slightly better than 2-1, not as impressive as the M18 Hellcat battalions that achieved 5 or 6-1. But the 823 had fought in some of the most difficult battles of the war, from the hedgerows of Normandy to the frozen forests of the Ardennes. They'd proven that properly used tank destroyers could stop German armour even when outnumbered and outgunned. Springfield survived the war and spent 20 years teaching tank destroyer tactics at Fort Knox. His lectures emphasized the same lessons he'd learned at Mortain and Stavelot. Superior equipment means nothing if you use it stupidly. Inferior equipment can win if you use it intelligently. Mobility matters more than armor thickness. Positioning matters more than gun caliber. And the crew that shoots first usually wins, regardless of what they're shooting from. Those weren't the lessons German panzer crews had learned. They'd been taught that thick armor and powerful guns would protect them, that superior engineering would compensate for tactical mistakes. The 823 had taught them differently, one destroyed Panther at a time. The M10's combat record across all battalions tells a broader story about American armored warfare in World War II. Total M10 losses in the European theatre were 500 to 39 vehicles. That's out of approximately 6,000 produced, meaning about 9% of all M10s were destroyed in combat. Compare that to German tank losses. Of 12,000 Panzer IVs built, over 9,000 were destroyed in combat or abandoned, 75% loss rate. The 6,000 Panthers Germany built, 4,800 were total losses, 80% destroyed or abandoned. The Americans could afford to lose M10s because they could build replacements faster than combat consumed them. Germany couldn't. The production comparison reveals the industrial reality that determined the war's outcome. Fisher Body in Michigan could build an M10 in approximately 60 hours of labor. That included final assembly, not component manufacturing. The chassis came from existing Sherman production lines. The gun was a modified anti-aircraft weapon already in production. The turret was welded steel plate that didn't require specialized foundries. Put it all together using automobile assembly techniques, and you had a combat-ready tank destroyer in less than 3 days. A German Panther required approximately 300 hours of specialized labor. The armor plates needed specialty steel mills capable of producing complex curves and precise thicknesses. The interleaved road wheels were individual masterpieces of engineering that took hours to manufacture and install. The Maybach engine required precision machining. The final drive needed specialty gears cut to exacting tolerances. Every component demanded skilled workers using sophisticated tools. The result was a magnificent piece of engineering that Germany couldn't build fast enough or maintain effectively in field conditions. The reliability difference compounded the production disparity. M10 operational readiness rates typically exceeded 85%. That meant of 100 M10s in a battalion, 85 or more were ready to fight on any given day. German Panther operational readiness averaged 42% during 1944. Less than half their Panthers were combat-ready at any moment. The rest were broken, awaiting repairs, or being cannibalized for spare parts. You can't win a war when half your equipment doesn't work. The tactical lessons took longer to crystallize into doctrine. Tank destroyer advocates pointed to the 823's performance and similar success by other battalions as proof the concept worked. Critics noted that M10s were frequently used as infantry support guns rather than dedicated tank killers, suggesting the original doctrine was flawed. Both sides had valid points. The massed German armor attacks that tank destroyer doctrine had been designed to counter rarely materialized after Normandy. German forces were fighting defensively, using their remaining armor in small groups to plug gaps in crumbling lines. Tank destroyers adapted, supporting infantry advances and destroying whatever targets appeared. Flexibility proved more valuable than doctrinal purity. By war's end, American commanders had reached a consensus. Tank destroyers were useful, but they didn't need to be a separate branch with specialized equipment and doctrine. The M36 with its 90mm gun could kill any German tank, even Tigers and King Tigers, from the front at reasonable ranges. But so could the new Pershing heavy tank, with its 90mm gun, and the Pershing had better armor protection, making it more survivable in close combat. If tanks could kill tanks effectively, why maintain separate tank destroyer units? The Tank Destroyer Command was disbanded shortly after the war ended. The vehicles remained, redesignated as tanks or assault guns, but the branch and its doctrine disappeared. Springfield thought the decision was short-sighted. Tank destroyers had proven their worth from North Africa to Germany. The 823 alone had destroyed over 100 German armoured vehicles, played crucial roles at Mortain and during the Bulge, supported countless infantry attacks. Disbanding the branch didn't erase those achievements. But military bureaucracies measure success differently than combat veterans. The institutional army looked at the numbers and decided that tanks could handle the anti-tank mission. The tank destroyer branch was expensive, duplicated capabilities already provided by armoured units, and wasn't necessary in the emerging Cold War military structure. The M10 itself continued serving for years after World War II ended. Surplus vehicles were distributed to Allied nations under military aid programs. The French used M10s in Indochina during the 1950s. The Israelis mounted them with different guns and used them through the 1960s. The Republic of China converted them to self-propelled howitzers. The basic chassis proved so adaptable and reliable that nations kept finding new uses for vehicles that the Pentagon had declared obsolete in 1945, April 21, 1945. Magdeburg, Germany. Springfield climbed out of his M10 for the last time as a combat soldier. The 823 had been assigned occupation duties now that the fighting had ended. His crew gathered around the vehicle they'd named Slugger, looking at the battle damage that scarred its hull. Dozens of bullet strikes, shrapnel gouges from near-miss artillery shells, scorch marks from a German Panzerfaust that had struck the turret side but failed to penetrate. The M10 had brought them through battles that killed thousands. It wasn't the fastest tank destroyer. It wasn't the most heavily armed. It definitely wasn't the best protected. But it had been good enough. And in warfare, good enough equipment that works beats perfect equipment that doesn't. The cost comparison that began this story tells only part of the truth. The M10 cost approximately $48,000 to build. A German Panther cost somewhere between $120,000 and $300,000, depending on which accounting method you used and whether you included infrastructure costs. The American vehicle was cheaper, simpler, more reliable, and easier to replace. But those advantages meant nothing without crews who understood how to use them effectively. Morrison and his 601 Tank Destroyer Battalion at Guettar had proven the gun could kill German tanks. Springfield and the 823 had proven the towed gun concept, despite its limitations, could stop German offensives at Mortain. Then they'd proven the M10 could hunt German armour across Belgium and Germany when given the mobility to fight intelligently. The Germans had built technological masterpieces. The Panther was probably the best medium tank of World War II from a pure engineering perspective. Excellent armour, powerful gun, sophisticated fire control, everything a tank crew could want except reliability and availability. German industry couldn't build enough Panthers. German logistics couldn't supply them with fuel and spare parts. German training couldn't produce enough qualified crews to replace combat losses. All the engineering excellence in the world couldn't compensate for those fundamental failures. American industry built good, enough equipment in quantities that overwhelmed German production. The M10 wasn't perfect. The 3-inch gun struggled against frontal armour of Panthers and Tigers. The open-topped turret left crews vulnerable to artillery and grenades. The slow manual turret traverse made close-range engagements difficult, but none of those limitations prevented M10 crews from destroying German tanks when they fought intelligently. And American factories could replace every M10 destroyed in combat within weeks, maintaining battalion strength throughout the war. The tactical flexibility proved decisive. German doctrine was rigid. Advance using superior firepower and armour. Hold defensive positions using prepared fortifications. Execute textbook combined arms operations that had worked brilliantly in Poland and France. American doctrine was fluid. Use what works. Adapt to circumstances. If tank destroyers are more effective supporting infantry than hunting tanks, support the infantry. Matters more than armour protection. Emphasize mobility. The side that adapted faster won more often than the side with better equipment. Springfield's 30-year career teaching armour tactics emphasized those lessons to generations of officers. He showed them 823 after-action reports. He walked them through Mortain and Stavelot battles, explaining decisions crews made under fire. He emphasized the human factors that determined success or failure: crew training, tactical flexibility, understanding your equipment's limitations and fighting accordingly. The best tank destroyer in the world won't save you if you use it stupidly. A mediocre tank destroyer will win battles if you position it intelligently and shoot first. The M10 Wolverine story isn't about superior American technology defeating inferior German engineering. It's about superior American industrial capacity, tactical flexibility, and crew adaptability defeating German rigidity and resource constraints. The vehicle itself was adequate. Not exceptional, just adequate. The crews made it exceptional by using it intelligently. The industrial system made it war-winning by producing enough to equip dozens of battalions across multiple theatres. And American doctrine made it effective by emphasizing adaptation over doctrinal purity. By the time Springfield retired from teaching in 1965, tank destroyers as a separate branch had been gone for 20 years. But the lessons they'd learned remained relevant. Speed and mobility matter more than armour thickness in many tactical situations. Shooting first matters more than having the biggest gun. Reliability and availability matter more than individual vehicle superiority. Industrial capacity matters more than engineering sophistication. Those truths didn't change just because the institutional army decided to eliminate tank destroyers as a separate branch. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.